parents Very good evening, guys. How are you doing? Am I audible? Am I audible, guys?
You're audible.
Okay, hold on. Just give me a second, guys. All right. Yesterday we started with the thermostatic expansion wall, and we have come to the adjustment of it. Just give me a second. All right. I was telling about the setting which was there. There's something called an MSS setting. I just share that. Share my screen. Hold on. Minimum stable setting. We understood this that the temperature range of your thermostatic expansion wall, what it is. Now you see, as the temperature of the evaporator drops, the amount of the superheat increase. That means the superheat increases as the temperature drops. The amount of superheat in the suction line is largely determined by the refrigerant control. And the best superheat setting for evaporator is the point that causes the least sensing bulk temperature change while the system is running. That means you want to control your system that way. You can set it at one particular temperature. This setting is called as the minimum stable signal or MSS point or setting. For example, let us say I consider an example. The following data regarding operating behavior of a particular wall and evaporated combination. So at 12 degrees Fahrenheit or 6.6 degrees Celsius, superheat, the bulb temperature changes from 14 degrees Fahrenheit to 10 degrees Fahrenheit, 7 to 5.6 degrees Celsius, basically. And at 5.6 degrees superheat, it goes from 6.1 to 5 degrees Celsius. Similarly, at 4.4 degrees superheat, when you're saying the bulb temperature changes from 4.7 degrees Celsius to 4.2. And similarly, at 6 degrees Fahrenheit or 3.3 degrees Celsius superheat, the bulb temperature changes from 4.4 to 2.2. So, as per these four readings, the minimum stable signal point means that you want the thermostatic expander to be constantly stable would be at 8 degrees Fahrenheit or 4.4 degrees Celsius. Okay, superheat setting because it produces the smallest variation of the bulb. You see, at 8 degrees, okay, and somewhere between this, the temperature of the bulb change will not be that much. Okay. And 1 degree Fahrenheit or 0.68 degree of change is between the two the string readings. So that's why they're suggesting that 4.4 degrees is basically the best because see 4.7 to 4.2. So zero point 0.6 degrees is only the change of the temp of the sensing bulb temperature. Okay. So in order to make the system functional for the maximum efficiency, the superheat setting should therefore be adjusted to 4.4 degrees Celsius for this particular thermostatic expansion. So that means whatever the temperature, the changes in the temperature you want to have, the sensing temperatures, you should want to keep the variance as less as possible so that the super heat is constant all the time. Okay, so that you get the maximum efficiency. Okay, not that variance है तो इसके और time लगेगा to get the super heat. Okay, that is the idea. So this temperature at the evaporator drops, the amount of the superheat in the suction line, okay, that should, where the least sensing bulb temperature to change the system is running, that is called as a minimum stable setting. So that means for this particular thermostat expansion hole, 4.4 degree Fahrenheit, 4.4 degrees Celsius is a superheat setting which would be maintaining uh, the stable condition for the TX. Basically, you want to maintain it that way. Now, with regards to this, we will see the setting adjustment, how to adjust to this range. Okay. So first, let us see a TXV. So TXV expansion was an adjustment adjuster, basically for increasing and decreasing the spring tension inside the wall assembly. Typically, turning the adjuster clockwise increases the spring tension. Turning the adjuster counterclockwise reduces the spring tension. So you see the diagram first. So you see this is the adjuster stem at the bottom of it. So cross section showing the flow of the refrigerant through a diaphragm. Okay, like you see here, it was the full, okay, diaphragm type thermostatic expansion. Now you got a diaphragm on top and a sensing bulb coming onto the diaphragm. Again, this is like there is no talking about equalization over here at all. Okay. Now sensing bulb pressure applied to the upper space of the diaphragm, as you see here, and the lower side pressure, the spring applied to the bottom. The spring and lower side pressure, the blue one acting on the lower side. Okay. Now, low side pressure on the bottom keep the valve closed until overcome by sensing bulb pressure. The adjuster can be turned to increase or decrease the pressure on the spring, which changes the amount of sensing bulb pressures needed to open the valve. That means more amount of pressure will be required over here to then operate this. If you adjust the spring clockwise or anti-clockwise, it will reduce the pressure. So it will operate it faster. That is the idea. So if spring tension is increased, a larger difference between the spring sensing bulb and evaporating pressures will be required to open the valve. That means sensing bulb का और जो evaporator pressure है उसके बीच में ज़्यादा difference होना पड़ेगा ताकि pressure ज़्यादा बढ़ जाए on top of the diaphragm. This results in lesser refrigerant entering the evaporator because now the what do you call the spring tension will increase, so the valve will open less. Okay, and the refrigerant less refrigerant means it will be able to vaporize more quickly and begin to absorb more sensible heat superheat than previously. So degree of superheat will increase now because now less refrigerant is going, so more superheat will be gained. Now if the superheat setting is increased too far, that means आप उसको बहुत ज़्यादा tight कर दो, ठीक है? Refrigerant will evaporate partly through the evaporator, and this will reduce the evaporator's heat absorption capacity and overall system efficiency. So basically system efficiency will drop, and this is called as a starved evaporator, because now you're reducing the refrigerant, but reducing to such a degree that the refrigerant is not able to go throughout the entire evaporator, and starving is taking place. So उतना नहीं करना है आपको. You can throttle it a little bit so that you get more amount of superheat, so that you can just give maximum efficiency. But if you do it too much, then it is going to starve the evaporator. Okay, you don't want that. Now, if spring tension is decreased too much, a smaller pressure difference is required to open the valve. That means now, if you open it counterclockwise, the spring tension will be reduced. When this pressure is reduced, now this opening pressure will be lesser required. So that means that diaphragm pressure on top will be required lesser to open this TX. That's why degree of smaller pressure is required to open the valve, resulting in lesser superheat in the system. Now, if the superheat is reduced by too far, not all the refrigerant will evaporate before it leaves the evaporator. Again, this reduces efficiency and also increases the risk of the liquid refrigerant to be drawn into the compressor. For optimum performance, the valve should be adjusted to the superheat set at the maximum and a minimum stable setting point. जब एनालिसिस देखा था कि उसका constantly the superheat should be constant and the variance is very less. ये bulk temperature और इसके बीच में इतना फर्क नहीं पड़ना चाहिए. ठीक है. So the idea is that you can adjust this. ठीक है, to adjust the superheat, but by adjusting this, you are only changing the degree of superheat, not the room setting or anything. ठीक है, उतना वो कम नहीं कर रहे हो, कम ज्यादा नहीं करोगे. ठीक है, तो अगर आपको टेम्परेचर एडजस्ट करना तो इससे आपको कर सकते हो. Thermostat expansion or adjustment will only change the degree of superheat and how quickly or how later the room attains the temperature. वो कर सकते हो. ठीक है, बट आपका जो टेम्परेचर है उससे कंट्रोल नहीं. ठीक है, वो आपको कैसे करना पड़ेगा, वो आपको करना पड़ेगा बाय योर थर्मोस्टेट. ठीक है, थर्मोस्टेट विल बी doing that. So this is only going to adjust the degree of superheat. So clockwise, pressure increases, degree of superheat increases. Anti-clockwise, pressure decreases, so it will open at a lesser and a later superheat will be decreasing. That is the idea. More refrigerant will go, superheat will be less. That is the idea. So that is the basic idea how to adjust the thermostatic expansion. Okay. So basically, you should adjust to the MSS point. So not MSS point, the minimum stable setting. That the temperature differences should be ideally not too much. Inside the bulb. The bulb temperature, देखो ये 4.7 to 4.2 constant for 4.4 degrees superheat is ideal for this type of superheat. This particular example, not for everyone. Everyone will obviously have a different MSS point. Okay? तो वो आपको एक बार सेट कर लेते हैं. इसलिए the thermostatic expansion valve should not be adjusted generally. ठीक है, you can adjust it to change the superheat, but you should not generally adjust it because it is set at the MSS point by the manufacturer. तो ये आप कोई क्वेश्चन पूछता है सर्वेयर, why would you adjust the what adjustment would you do in a thermostatic expansion valve? ये adjustment है. क्यों करना है? You want to adjust the degree of superheat. इसको करने की जनरली क्यों नहीं करते? जनरली क्यों नहीं करते? बिकॉज ये एक एमएसएस पॉइंट पे सेट करके दिया. वो क्या बोलता है जनरली कि एक आइडियल सेटिंग पे करके दिया. दैट आइडियल सेटिंग इज कॉल्ड एज एमएसएस पॉइंट. नाउ यू नो द प्रॉपर नेम नॉमेनक्लेचर. ठीक है, तो ये नॉमेनक्लेचर अगर आप बोलोगे तो दैट सर्वे might appreciate it. He might not appreciate it also because maybe he might not know that name. He will just say that it is generally the ideal setting. The ideal setting is MSS point. Okay? Minimum stable setting. Now, the adjusting nut or screw is sensitive and it should never be turned more than 1/4 turn while the unit is operating. In addition, the system should be given 10-15 minutes to stabilize the previous setting before any adjustment is made. मतलब आप कोई भी adjustment करोगे तो instantly तो आएगा नहीं, तो degree of superheat that changes. So it will take some time to realize. Okay, 10-15 minutes though. So it's a trial and error process. So and not more than 1/4 turn at any given time. Actually कैसे करते हैं ना इसके ऊपर when you are adjusting this, I've seen one somewhere a video of this. क्या करते हैं, you open this and you make one long mark on the stem of this, ठीक है, and you make a 90-degree mark also on that and a mark on the body. So initially एक mark है और एक 90-degree पे mark है and you on the mark on the body. So you have a reference point how much angle you are turning. So वो ज़्यादा quarter भी नहीं, 1/4 turn भी quarter से भी आधा, मतलब 1/8 turn कर दिया, फिर आप थोड़ा किया, फिर 1/8 turn किया, फिर उसके हिसाब से आप चेक कर सकते हैं. ठीक है, so you can adjust the temperature range, but generally this is not the correct way to do it. Correct way is by the thermostat. ठीक है, तो अगर आपको thermostat range के अंदर है तो ठीक है. Now इतना समझा आप लोग को how this adjustment is done and why this adjustment is to be done. Okay? That generally why you're not doing it because it is set one time at the constant point. Okay? Generally इसको आप कभी नहीं करते. Now hunting. Now sometimes hunting they ask what exactly is hunting of the TXV and how to remedy. Okay. So hunting, the term hunting refers to responsive mechanism going too far in one direction and then overcorrecting and returning too far in the other direction. Basically, you attain what do you call desired output, but you overcorrect, and then you now go in the other side and you undercorrect. So, matlab it is like going up and down around the same point. You will not be able to getting a constant what you call flow. This may also be referred as surging. Okay. The term hunting is used with reference to refrigerant system identify the change in refrigerant flow through the refrigerant control. Okay. If the wall hunts, it will alternately open up too wide, allowing too much refrigerant to flow into the evaporator, and then close too far, not allowing enough refrigerant into the evaporator. Each extreme change reduces the evaporator efficiency. मतलब या तो वो बहुत ज़्यादा खुलेगा या बहुत कम खुलेगा. If less hunting, the more effective the system will be. Basically, it is almost constant. When the wall is hunting too much, a uniform amount of refrigerant is not provided to the evaporator, and hunting may even allow liquid refrigerant to reach the compressor, causing the compressor damage. In some cases, hunting is caused by the wall, which is too large for the system. मतलब अगर it is not matched properly, ठीक है? तो जनरली ऐसा नहीं होगा कि TXV तो आप ऐसे ही कोई ना कोई TXV नहीं लगा दोगे ना. You will have the idea of the flow rate that is there and what is the requirement of the size. ऐसे directly आप लगा नहीं दोगे. Okay. Now each TXV wall and evaporator combination has to be properly sized for the application. In addition, the TXV wall must be properly adjusted. The super heat adjustment should keep surging and hunting to a minimum. However, it should still permit full evaporator use. Means the evaporator should be getting the entire evaporator should be in the use, not partly of the evaporator. Okay, that is right. Now, next is design of this. Okay. TXV is the assembly is a brass body to which the liquid line and the evaporator line are connected. The wall and the seat are housed inside the wall body, and the wall is joined by flexible metal bellows or a diaphragm. So you can have a bellows control or a diaphragm control, either or. That means on the top of the this thing again. The wall is moved by a rod connected to the other end and sealed bellows or diaphragm power element, basically the power element. The capillary tube connects the sensing bulb to the top of the THV above the sealed diaphragm. Okay, so this figure shows the temperature changes in the sensing bulb translates to up and down movement of the wall. Okay, the wall assembly is sealed to prevent further refrigerant from seeping out and moisture from seeping in. मतलब एक बार वो बंद हो जाएगा तो वो बंद हो जाएगा. ठीक है. A filter dryer should be placed in the liquid line ahead of the TXV and a strainer screen located between the liquid line connection and the wall assembly. The strainer keeps the dirt away from the wall and walls. एक छोटा सा strainer होता है. ये दिखा रहा है देखो कि एक बल्ब कूलर है और ये लिक्विड लाइन है, सक्शन लाइन है, ये लिक्विड लाइन है और ये आपका ये रेडिएशन है. And now the effect of sensing temperature on the thermostat expansion. A sensing bulb is cooled and the pressure is low and considerable quantity of control fluid is sensed in the bulb. As you see here, it is cooled, so यहाँ पे pressure कम हो गया. ठीक है. Similarly, sensing bulb is warmer. Now it is warmer. Okay. The same control fluid, whichever is fluid inside, has evaporated. Now it is no longer it is evaporated, and the vapor is pushing the diaphragm downwards. Okay, and the operation of the valve. Okay, for accurate control, therefore, it must be enough control fluid in the sensing bulb to ensure that it never completely evaporates. So one time I was seeing one question is also there. The one sir, I think it was by Vijay Yadav. Okay, what is the fluid inside this? What is the guys? What is the fluid inside this? Is the sensing
Same refrigerant, sir. Same refrigerant which we are using.
You are partly correct, but sometimes there is a different refrigerant, sometimes there is a different, completely different refrigerant, sometimes there is a separate fluid. We will cover that because same refrigerant is their general idea. Okay, but sometimes some manufacturers have different ideas also. Why they have, because we'll cover that also. But we just know the different configurations. But generally, you have the same refrigerant only. Okay? But there are possible, there are some other configurations also we will see today. आगे देखेंगे. सो ये देखो, ये एक और TXV है जो आपका along with that there is a ball wall instead of needle wall. This can also be possible. Like we saw this TXV with the needle wall arrangement, which is a common, which I see the diagrams everywhere. So instead of a needle wall, there can also be a ball wall like this. So ball wall can also be there. This can also be there. This is also acceptable. Idea वही है कि वही चीज कर रहा है, but now instead of a needle wall, there is a ball wall. Adjustment भी इसका वैसा ही है, नीचे ऊपर नीचे, और ये सुपर हीट का स्प्रिंग है, एडजस्टमेंट इसका वैसा ही ऊपर नीचे करने के लिए ऐसे ही बॉल वॉल इज बेसिकली पावर पिस्टन बॉल विच इज बेसिकली मूविंग अप एंड डाउन, और उसका जो क्लियरेंस है वही वैसे ही काम करेगा जैसे नीडल वॉल काम कर रहा था, ये भी वैसा ही काम करेगा. ठीक है. So now we talk about internally equalized thermostatic expansion valves. Okay. Now, in order to sense the low side pressure in the system, the bottom of the thermostatic expansion valve diaphragm must be exposed to the low side pressure. That means on the other side pressure. In internally equalized thermostatic expansion valves, a small passage connects the chamber underneath the wall, the diaphragm, to the wall outlet. This keeps the bottom of the wall diaphragm exposed to the low side pressures at all times. So the bottom side is always coming to the low side pressure. The connection between the lower diaphragm chamber and the wall outlet may be maybe a passage cast or bored into the wall. It could be a internal passage, or it could be a separate external, what you call a pipe also. Okay. Or it may simply be a large clearance around the wall push rod. So basically wall push rod के अराउंड की क्लियरेंस होगा तो वही उसके ऊपर आपका वो जो चले जाएगा प्रेशर. ठीक है. That allows the refrigerant to leak fast. Now, in internally equalized TXVs, the bottom of the diaphragm is exposed to the evaporator inlet pressure, and the top of the diaphragm is exposed to the sensing bulb pressure, which is related to the temperature in the evaporator outlet. Therefore, internally equalized valves do not provide accurate control when used with evaporators that have a large pressure drop between inlet and outlet. When there is a large pressure drop in inlet, what will happen is inlet will be at a different temperature, outlet will be at a different temperature. So the pressure drop will occur because the different temperature ranges, okay, and the pressure ranges. So उसके वजह से क्या होगा, the outlet will not be sensing the actual condition, okay. So that means there will be a pressure drop and you will not get a very precise control, okay. So give me a second, one second. All right. So now externally equalized sensing thermostatic valves. Why do you require them? That is the question first. Okay. So as there is a large pressure drop across the TH3. Okay, so you will require external equalized thermostatic expansion valves. Now, the design is a little bit different than the other design. You'll just see that. An externally equalized thermostatic expansion valve has an external equalizer that connects the suction line of the evaporator outlet to a chamber inside the expansion valve, just below the diaphragm. Now, the equalizer is a small tube connected to 1/4 OD, or the outer diameter. You see the figure. because the equalizer diverts the pressure at the bottom of the diaphragm that is equal to the pressure at the evaporator outer outlet rather than the evaporator inlet. Otherwise, what is happening is evaporator inlet का pressure आता है ना, यहाँ पे क्या करेगा direct evaporator outlet का pressure दे देगा. Okay, so this is the you're able to guys see the screen, right? You guys are able to see screen, right? तो दिख रहा है ना आप लोग को?
Yes, sir.
Okay. So this is an externally equalized thermostat expansion. Now you see, always the thermostat expansion or externally equalized will be connected, okay, downstream of the evaporator, ahead of the sensing bulb. Okay, sensing bulb के आगे होगा. Okay, that is the idea. And there's always the what you call ahead of it. Okay, I had a measurement of this also somewhere. कितना millimeter? I think 150 millimeter. I have to just confirm this. Wait, I'll just check it where it is. एक मेरे पास था इसका measurement भी कितना कितना था. What is the ideal measurement out of this idea? But idea क्या है कि ahead of the sensing coil. Okay, that is the idea. And this is your external equalization connection. Okay. So, with the equalizer, the connected equalizer diverts the suction line pressure at the sensing bulb location. Means जो return line जा रहा है suction line का pressure वो direct यहाँ पे आता है rather than this pressure coming at the under. Okay, and this equalizer diverts the suction line pressure at the sensing bulb location to the underside of the wall bellows or the diaphragm low pressure side. This compensates for any pressure drop to the evaporator while the compressor is still running. Okay, so that means equalizer is a small tube, usually 1/4 inch outer diameter. Okay, because the equalizer delivers the pressure at the bottom of the diaphragm that is equal to the pressure at the evaporator outlet rather than the evaporator inlet. Okay, the valve compensates for any pressure drop to the evaporator. This allows the valve to provide a correct refrigerant flow even when there is a large pressure drop to the evaporator. It means whatever the pressure drop doesn't matter. Now you're getting a direct representation of the outlet of the evaporator. The thermostatic expansion valve equipped with the external equalizer is shown as in this figure as we saw. This is always some pressure drop through the evaporator. The equalizer should be used if the pressure drop is between the inlet and evaporator is more than 4 psi or 28 kp. That is understanding. कि अगर 4 psi से ज़्यादा pressure drop है तो equalizer should be external. The equalizer provides the same pressure as in the suction line with the sensing bulb location. The equalizing of the pressure will permit accurate superheat adjustments, and the pressure drop in the evaporator tends to increase the superheat effect, which in turn causes the valve to restrict the flow more, leading to starved evaporation. So that means equalizing pressure will basically permit accurate superheat adjustment. That is good. But pressure drop in the evaporator tends to increase the superheat, which in turn causes the valves to restrict flow, leading to starved evaporation. Okay, that is the idea. This is again the equalizer connection. How it is? This is inlet outlet. This is the equalizer connection. This is a TXC actual one. How it looks like. So there is the equalizer connection coming on. Now there is something. There is one design. Which is like this is a basic design where you had an external equalizer. Just to give you a second. I had a measurement of this. I'll just tell you once again how many millimeters was there. I had some rule of it. Hold on. One of you just send this across to me because I had this written down somewhere. Can you just send this to me in a private message? No? The distance of the bulb from the equalizing connection ऐसा एक था just send it across to me. I will just find it out. I remember it somewhere I had because उसका photo नहीं मिल रहा अभी. So this was asked some time back. Okay, what is the distance or something they had asked. Okay, what is the perfect position for the bulb and something like that. तो मैं एक बार देखा था मेरे को भी याद नहीं आ रहा है कहाँ देखा था मैंने. It was in some notes or some handwritten thing or I have to just check my notes. Okay, that is idea. So now we have understood this thing. We will just understand now there were different design of TXV with something called a bleed walls and bleed ports. Okay. Now basic idea क्या है? Some TXV walls like those used in many AC systems are equipped with bleed walls for rapid pressure balancing. Now these type of valves allow a compressor motor with low starting torque to be used in this type of system. Like basically low starting torque क्यों चाहिए? Because अगर आपको unloader नहीं लगाना system में, you need something to equalize the system, right? In this type of TXV, a secondary port opens when the compressor stops running, and the refrigerant flows through the secondary port quickly, equalizing the pressure between high side and low side. Now जब stop होता है, तो pressure is equalized हो जाता है. ठीक है? Now the compressor operating the secondary port when the compressor starts operating, the secondary port closes, and then the valve operates in a normal manner. This is a normal TXV काम. Other TXCs equipped with a fixed speed ports that gradually equalize the low side and high side pressures when the compressor is off. Now, even your automatic expansion valve have got these type of designs where you've got bleed ports and bleed what you call valves. Okay, we'll see both of these designs just now. So basically, these gradually equalize the low side and high side pressure when the compressor is off. These bleed ports are typically very small and do not adversely affect the normal performance. However, when the compressor stops, enough refrigerant is able to pass through the bleed ports to equalize the system pressures in 3 or 5 minutes. Like RPP TXVs, your bead float TXV, the thermostat expansion valves equipped with fixed bead floats are used in systems that have motors with low starting torque. Okay, now you've got two designs. You've got one design, a simplified TXV with a bleed float. So you see this bleed float is there is a very small idea in comparison with the high pressure line and the low pressure line. So this is always connected and this always will allow little amount of the equalization to take place from the low side to the high side. It will not affect the normal operation of the valve. But very small amounts are going. Okay. But when the system is off cycle, when the valve is shut, it will basically equalize slowly the low pressure to high pressure side. So there's a representation of the mechanism. Okay. One second. So basically, these bleed ports or a valve, basically they're controlled by what you call basically secondary port is always open, which is very small, and it is not affecting your control. Basically, your effective is not happening. Okay, so this rapid pressure balancing happens. Okay, जैसे ही स्विच ऑफ हो जाता है वो उसको ओपन कर देगा एक ब्लीड पोर्ट के थ्रू. ठीक है, और एक सेपरेट एक वॉल्व भी हो जाएगा which will be controlled by a solenoid. ठीक है, एक solenoid controlled valve भी हो जाएगा which is having this thing. तो उससे रैपिड प्रेशर बैलेंसिंग हो जाएगा और ये ब्लीड पोर्ट से धीरे धीरे होता है. ठीक है, तो रैपिड प्रेशर बैलेंसिंग में इंस्टेंट एज सून एज यू स्विच ऑफ द मोटर देयर विल बी a solenoid valve which is connected to this bleed port के यहाँ पे. So valve will open and it will allow the system to go through. If this valve is not there, simply a port is there and it will always open and it will not affect the efficiency of the system. The basic idea. Now, sensing bulb variation. This is what was asked by, I think so, Vijay Yadav sir. So, what is the different? What is the sensing bulb type? Okay. So, the sensing bulb used in TXVs can be divided into 5 types based on the type of the fluid filling the bulb. Okay, what is the fluid filling the bulb? Now, each variation of sensing bulb charge changes the operational characteristics of the valve. Means how the valve will act will change. This means that the type of sensing bulb charge used in TXV will affect how it reacts to the condition within the system. Means whatever is the sensing bulb, उसी के ऊपर तो उसका आपका ऊपर का diaphragm का pressure जाता है. So if you've got a different idea inside that, you said the same refrigerant is always there. That is not the case. You have got different ideas for different controls of different circuits. So you see all of them. For this reason, it is extremely important to give select the proper thermostat expansion valve for given application. The following are 5 different types of charges used in TXV's sensing bulbs: liquid charge, gas charge, liquid cross charge, gas cross charge, and absorption gas charge. Like there are 5 different types. Okay. I just explained the 5 types. We won't go in depth in it because it's not required right now. Now, each manufacturer has a code for identifying the fluid that charges the sensing bulbs. Some use letters, some other use colors or numbers. So basically, some letter will be there or color or number. तो manufacturer के हिसाब से आपको उसका index देखना पड़ेगा, and you'll come to know what is the idea behind it. Some valves are marked with refrigerant number. Others are color coded to identify the refrigerant on which they are to be used. This figure shows the several thermostat expansion valves identified by standard color coding. Green indicates the valve designed with the use R22. Light blue is for R134A and yellow is for R12. तो ये भी आपको कभी-कभी पूछते हैं, can you use any TXV on any system? No, it is also sometimes designed for use with a particular refrigerant. तो because का sensing bulb के ऊपर depend करता है, ठीक है? तो वो आपको देखना पड़ेगा. This is the idea. You see different 3 TXVs. The labels on the TXVs have power heads. Okay, like this is a power head, which are color coded, which include the alphanumeric designation of the refrigerant in which they are designed to use. जैसा इसमें लिखा हुआ है. जैसे ये R12, R22 and R120 or 23A ये लिखा होगा. ठीक है. Let me just get the brief of this. Just give me a second.
सर आप म्यूटेड हैं सर.
Just hold on. I'm just opening the page for a different idea. Because I don't want to talk about too much of the different media which is there inside the bulb. Just give me a second. मैं अपना वो नोट्स खोल रहा हूँ जिसमें लिखा था कि क्या क्या किस स्पीच का है. Just give me a second. All right. So your this liquid charge sensing bulb is used in air conditioning and refrigerant systems, and the liquid charge sensing bulb is charged with the same refrigerant in the system. This is the idea which is generally there for 90% of the systems. Okay. Now the quantity of the fluid in the liquid charge sensing bulb is sufficient, so there is always some liquid in the bulb regardless of the temperature. मतलब जितना भी temperature है the system, तो काफी bulb है तो हमेशा liquid रहेगा इसमें, ठीक है? Because sensing bulb is charged, sensing bulb charge and evaporator is filled with the same refrigerant, the pressure inside the bulb changes at the same rate as the pressure inside the evaporator. तो जैसा वो refrigerant inside the evaporator रहेगा, वैसा ये liquid charge refrigerant जो है ये भी react करेगा, ठीक है? At the same rate pressure change हो जाएगा in the evaporator, same rate inside the what do you call sensing bulb होगा. Thus the valve maintains a constant superheat or compressor superheat setting is maintained constant. ठीक है? That is that. So this is the idea advantage of the liquid charge what do you call sensing bulb. Okay. So इसके ऊपर we don't want to talk about much more. Just give me a second. There is something called a liquid cross charge. I'll come to the gas charge in a minute, but liquid cross charge. Okay. So suppose liquid cross charge means basically the sensing bulb use a refrigerant that is different from the one in the system. But again, there is a lot of refrigerant inside it, so it will basically have liquid inside it. And now which we were using for basically different refrigerant, okay, than the one in the bulb. So liquid cross charge means basically different refrigerant, which is have reacting differently to temperature and pressures, okay. So you want it for some reasons over there. Okay. Now the liquid cross charge the sensing bulb may be using a mixture of different refrigerants to achieve the desired operating characteristics. Okay. Liquid cross charge bulbs may have many similarities with liquid charge bulbs. Okay, because some liquid is always in the bulb, so it controls in the same manner. So basically, the control can be faster, and you can achieve the superheat faster in the some type of evaporators, like large evaporators. You can use this liquid cross charge, because now you want the TXV to operate at a different what you call characteristics. Maybe you will have the TXV design little bit different than what is required. Because that is the reason why you're having this cross charge. Cross charge means basically you're putting a refrigerant but in the liquid form, and you're having it at a uh, different refrigerant containers. So idea क्या है? You are able to reduce as the suction pressure is reduced, the superheater is reduced, and thus maximum you're able to cover more amount of evaporator surface by the refrigerant. Hunting is reduced because you are getting a much more smoother operation. Okay, and this thing, and valve reaction is faster when you're utilizing a liquid cross charge bulb. Okay, hunting is reduced, valve reaction is faster, and you're able to get the superheat at a faster reaction. Okay, and your compressor will basically stop faster. Basically, your running out the compressor will be reduced. That is right. Now, gas charge, ये जो पहला वाला है, gas charge. Okay, so gas charge sensing bulb uses the same refrigerant as in the system, but amount of the charge means amount of the actual refrigerant inside the bulb is such that the liquid is always vaporized at a predetermined temperature. Means हमेशा वो vaporize या gas form में ही रहेगा inside. So it is not being the liquid form. Okay, and as a result, the expansion valve does not operate. It operates the pressure basically so increasing a temperature above the predetermined temperature जहाँ पे है. Okay, the pressure will be rising very slowly inside the top part of the TXV. उसका वो जो pressure है वो धीरे धीरे operate करेगा. However, if the wall wall body starts getting colder, okay, then vaporization will be faster. And idea क्या है, the wall will close faster, and basically you can operate the range from minus 1.1 degrees to 15 degrees, 15.6 degrees Celsius. That is the range. ये पहला वाला जो था, ये जो liquid cross charge था, इसका range है -40 to 4.4 degrees Celsius. That is the operating range. और ये जो liquid charge refrigerant का range है, operation है, it is basically -28.9 to +4.4. So idea क्या हो गया, gas charge कर दिया, so you are able to get your operational range basically having a much more larger range. Okay, that is the idea. For -1.1 to 15.6 degrees Celsius. So that is the reason you would want to take this gas charge refrigerant. But the problem is that the control will be smaller. Okay, and you'll be basically the reaction time of the wall will be slower, and you will be able to get the entire thing operating very slowly. So ये भी एक requirement है in this. Similarly, when you have got gas charge and liquid charge, you can also have gas absorption, gas cross charge. The gas charge cross charge का मतलब again refrigerant in the system is less, but now a totally different refrigerant from the system refrigerant. Okay, that is the idea of the gas cross charge, and it is again such yes that once the temperature is desired temperature is reached, all the temperature in the bulb is vaporized. So उसके बाद pressure नहीं बढ़ेगा, and the pressure rise will be very small, and maximum operating pressure के पास में ये ऊपर वो pressure drop इतना ज़्यादा नहीं होता है. So that is one more reason why you operate it. You don't want the reaction of the TXP to be very more. That is also one reason we want to take a gas cross charge refrigerant something more. Now last one is this absorption type gas cross charge. तो ये क्या है, some types of gas cross charge sensing bulbs depend upon a different principle. मतलब ये temperature sensing के बारे में नहीं. Now in thermostatic expansion bulbs with the sensing bulbs, the bulb contains two substances. So इसकी special absorption bulb के अंदर तो एक substance क्या होगा? Basically one is a non-condensing gas such as carbon dioxide, and the other is basically a solid such as carbon, silica gel, and charcoal. The ability to absorb the gas. Okay, so absorption is basically there is no chemical combination between the absorbent and the gas. मतलब जो आपका जो कार्बन डाइऑक्साइड डाला गैस डाला है और वो जो चारकोल या ये है वो रिएक्ट नहीं करना चाहिए. ठीक है, तो आइडिया क्या है कि इससे you can have a very wide range of temperature. Okay, the temperature range is basically for this is you go from minus 20 to plus 60 degrees Celsius. You can have it because now this you have a different gas and you have an absorption also. Okay, so basically क्या होता है कि once the at a particular temperature the whatever is the solid will keep absorbing the refrigerant. Okay, and to absorb it at a low temperature. As the temperature keeps increasing, the sensing element, that is the bulb, keeps warming up, and the pressure will keep on increasing. Now, due to this, जो भी absorption किया गया था वो जो solid है, जो भी आपका जो चारकोल या सिलिका जेल या कार्बन है जो absorb किया था, वो भी release करने लगे, because pressure temperature बढ़ा. As the temperature बढ़ता रहता है, absorption will release more and more gas, and the pressure will release faster. So that is the reason you are able to get the wider temperature range which is there, with up to from minus 40 to up, almost up to minus 20 to up to plus 60 डिग्री जो एबल टू गेट. ठीक है, दैट इज राइट. तो ये आपका जो रेंज है ये रेंज हायर रेंज बिकॉज ऑफ द एब्जॉर्प्शन प्रिंसिपल. तो दिस इज जस्ट टू अंडरस्टैंड, इतना पूछेंगे नहीं, बट इफ यू आस्क यू जस्ट हैव टू टेल द लिक्विड चार्ज इज द मोस्ट ऑफ देम. Otherwise, you got gas charge, the separate with the same liquid refrigerant, lesser volume. Then you got liquid cross charge, basically different refrigerant. You want the THC to operate faster or lesser, you can change the THC, or the gas cross charge. Same way, it's basically this. You are having a different refrigerant in a gas. And last is absorption gas cross charge. Okay, it is right. And you can have them actually color coded and difficultly you can have them marked also. That is right. Just give me a second. Let me drink some water, please. Now, location of the sensing bulb. ये अभी आपके वार्ड सर का काफी अच्छा क्वेश्चन है about where the sensing bulb is located. Okay. Now, the sensing bulbs location is very important. The bulb must be is in good contact with the evaporator outlet, and how it is secured also कभी कभी पूछता है. Okay. So on systems with a small diameter horizontal suction line, ये छोटा diameter आपका line है, and the suction lines are small. The sensing bulb should be mounted on top of the suction line, as shown in this figure. You see the figure 20A. ये देखो, ये small suction line है, तो हमेशा on top of it, on the horizontal axis, right on top. ठीक है, small suction line. Now, if the bulb is mounted in a vertical suction line, so the horizontal suction line तो ऐसा हो गया, but the vertical suction line, the capillary tube of the bulb should always enter from the top of the bulb, never from the bottom. As you see here, the capillary tube is entering from the top of the bulb in vertical line. मतलब नीचे तो नहीं एंटर करना चाहिए, वरना उल्टा हो जाएगा. तो क्या आपका प्रेशर ड्रॉप में बढ़ जाएगा आपका, क्योंकि प्रेशर बेसिकली here you want to send the pressure directly होगा. अगर ये capillary tube नीचे आ गया, तो फिर ये उल्टा हो जाएगा. So if you're making, if you ask you to draw this, no, if you're making it horizontal, make it like this. If you're making it vertical, you always make the capillary tube on top, not bottom. Okay. Next thing, the bulb must not be affected, okay, by the air or liquid being cooled. Basically, it should not be affected by the air or liquid being cooled. Actually, the whatever is the thing. Okay. Now it should be wrapped in insulation so that only suction line temperature affects the bulb, not the ambient air or the liquid which is being cooled. Okay. So basically, a special insulation foams are available that fits snugly around the sensing bulb, capillary tube, and suction line. How they are looking like this, like around the entire thing is here. So the ambient air will not have an effect on this. Only the actual suction line temperature, means return line temperature, will have the effect. Okay, this is the idea. the sensing bulb is properly insulated, तो एक पूरा insulating form है, तो उसके ऊपर वो लगा के you are having it entirely, so it is not actually affected by the ambient air or the liquid or whatever is in the air. Okay, that is basically. That is one idea. Just hold on. Then the sensing bulb must have excellent thermal contact with the suction line. Some sensing bulbs are crimped or other creased lengthwise. You see sometimes sensing bulbs are crimped to provide double contact with the help of with the help to align the sensing bulb with the surface of the suction line as it is figure. So what they're saying basically some sensing bulbs are like this is the top sensing entire, तो इसके ऊपर एक क्रिम्पिंग डाला ये बल्ब के ऊपर, ठीक है, ये बल्ब को क्रिम्प कर दिया ताकि डबल द कॉन्टैक्ट सरफेस मिल जाए. ओके, a crimp runs along the center line bottom, like you see the bottom से देख रहा है तो ये crimp दिख रहा है ऐसा line, and this is how it looks in a sectional view. A crimp sensing line contact the suction line at 2 points rather than one. So basically, double upper contact is one more idea. Okay. Now the contacting surfaces of the tube and the sensing bulb must be clean and connection must be tight. Both the suction line and sensing bulb should be cleaned and with steel wool before sensing bulb is installed. Copper strops and non-rusting machine screws and nuts should be used to fasten the bulb to the suction line. So what is connected? How are you connecting it? Not by any wire or anything. You're connecting it by copper straps and non-rusting machine screws. Again, nuts. Basically, again, you've got the basically non-rusting should be there and nuts should be used to fasten the entire thing, not by anything else. Then the suction line, however, carries the refrigerant that is mostly vaporized. Okay. Suction line carries the refrigerant that is mostly vaporized. However, there will be some droplets of the liquid refrigerant and some oil always. Now, this figure shows the condition inside the various types of suction lines. In refrigerant vapor and some droplets, the liquid refrigerant are shown flowing through a large diameter suction line. Due to the large diameter, the velocity of the vaporized refrigerant at all times will be quite slow, and droplets of the liquid refrigerant and oil will settle at the bottom of the line. So, what he's trying to say, you see, here you have why always have the sensing bulb on top of the line. That is what he's saying as. So, क्या हो रहा है? You have a line like this, A and B, what they're trying to show. The flow conditions shows a large diameter horizontal line, okay, and a small diameter horizontal suction line. This one. स्मॉल डायमीटर एंड लार्ज डायमीटर. तो स्मॉल डायमीटर है तो ऊपर और नीचे दोनों साइड पे आपके ऑयल लग जाएगा, तो धीरे धीरे. बट लार्ज डायमीटर है तो ऑयल नीचे लग जाएगा एंड ऑयल विल बेसिकली बी अ इंसुलेटर एंड दैट इज व्हाई यू ऑलवेज हैविंग द बल्ब ऑन टॉप नॉट ऑन द बॉटम ऑफ इट. ठीक है, दैट इज वन क्वेश्चन आस्क्ड व्हाई यू आर ऑलवेज having this bulb on top of the line. Okay, the idea answer is why always on top. Basically, the idea is that always on top because you don't want the oil to basically go and insulate. Okay, suction like refrigerant mostly vaporize, some oil basically there. Okay, right. The diameter of the suction line is smaller. As a result, the velocity of the vaporized refrigerant will be higher, and this is due to the insulating quality of the oil that is inside the suction line. That is why proper mounting of sensing oil is critical. So smaller है तो यहाँ पे insulation को आप insulating always will be there. Suction line छोटा है तो insulate because the oil is going to go on both sides because the velocity is higher in that. So the oil is going to coat all the sides. So oil is always going to insulate. So whatever the TX we are using, you are compensating for that by considering that that temperature drop, which is temperature basically across this the insulation which is happening, उसको आप लेके आप उसको बनाओ. But larger section line है, that is guys always on top because oil is basically at the bottom side. That is right. And similarly, अगर vertical section line ही है of a large vertical section line, you have oil on both sides because vertically basically it is going to act vertically downwards and oil is going to be coming onto Hi guys, welcome back. Okay, sorry about that. Can you just make me the host, please, again? Thank you. Thank you. Okay. So what I was showing you, let me just open the photographs again. So, give me a second. All right. So where was I? Just give me a second. All right. So we had completed this oil thing and where the position of this thing is there. Now, capacity of TXP. How is thermonuclear expansion wall capacity decided? So you see, the capacity of TXP will vary according to following characteristics. First is orifice size. Second is pressure difference between high side and low side. And third is temperature and condition of the refrigerant in the liquid line. What is the temperature and condition of the liquid? It will basically depend on that. The capacity of most TXVs is based on the size of the orifice and the pressure difference between the high side and low side of the system. The same wall body may be used for many capacities. That means if you have got the same wall body, you can't tell the capacity is same. Orifice could be changed. Okay. Larger the orifice, the more liquid refrigerant can be fed from the evaporator for a given time. And wall assemblies are rated in tons for refrigeration. Okay. However, the same orifice usually has three different tonnage capacities. The capacity range depends upon the pressure difference between the high side and the low side. Increasing the pressure difference will increase the rate of the refrigerant flow. Means अगर आपको refrigerant flow आना तो pressure difference बढ़ा दो, तो faster it will flow. It is important to use a valve of the correct capacity with an undersized wall orifice. The evaporator will be stopped regardless of the superheater setting, and the full capacity of the evaporator cannot be reached. If the orifice is oversized, the wall will hunt or surge, and when the wall opens too much, the refrigerant will pass into the evaporator. The suction line will sweat or frost before the sensing valve can can close the valve. Increasing the superheat setting to correct the condition results in the evaporator being starved too much of the time. As you saw, if you change the setting, so starving the system. So that's why thermostat expansion capacity should be matched to the system size and everything. Okay. Now, there's something called a pressure limiter. It is not that important. Okay, we just understand the concept behind it. See, ये एक यहाँ पे on the upper what you call line of your TXV there is again a separate what you call pressure limiting element. तो मतलब क्या करता है ये pressure लेता है but it will not give the full pressure down here. Okay, that means the pressure which is coming onto the there's one diaphragm on top and one diaphragm at the bottom. There is a collapsible diaphragm and there is the other diaphragm on top. Okay, so the pressure limiting element consists of two diaphragms and a spring. बीच में स्प्रिंग है और एक डायफ्राम है ओके whenever suction pressure near the motor overload point the spring between the two diaphragm compresses the valve reduces the flow of the refrigerant to the diaphragm तो ये प्रेशर लिमिटर टाइप का है तो अगर आपका ओवरलोड पॉइंट पे आने लग गया है तो ये आपको फिर प्रेशर को दबा देगा ये स्प्रिंग को एंड एट दैट टाइम द टीएक्स विल open more to limit the flow of the refrigerant to give the more flow of the refrigerant it is idea तो ये वही आइडिया है कि pressure limiter is there you can have it okay so when either the pressure limiter is designed to collapse at 40 psi the valve will close if the low side pressure exceeds the amount regardless of evaporated temperature and pressure फिर वो एक सेफ्टी ऐसा बनाया हुआ है during the off cycle the suction pressure is kept to in the pressure limit it will ensure that the compressor is not required to pull down the high pressure at startup in expansion was equipped with this type of pressure limiter often rapid pull down of the startup and thus require lesser startup for the compressor again ये startup limit करने के लिए ये है एक आइडिया है कि अगेन वो प्रेशर राइज को इक्वलाइज करने के लिए ये एक आइडिया है कि यू कैन हैव दिस प्रेशर लिमिटर एक ये प्रेशर लिमिटर डिजाइन है आगे भी इसके बारे में थोड़ा है वी डोंट वांट टू रीड मच अबाउट इट इसका वो पूछते नहीं आ रहा बट आई जस्ट वांटेड टू टॉक अबाउट नाउ व्हाट इज मोर important is automatic expansion valves what are these we understand them okay so because they ask what is automatic expansion valve thermostat expansion valve and electronic expansion valve and what is the difference between this all three so automatic expansion valve or AXV or pressure controlled expansion valve is a metering device that operates based on low side pressure मतलब डायरेक्टली ऑन लो साइड प्रेशर अभी वो क्या कर रहा था हम लोग पहले सेंस कर रहे थे कैपेसिटर बल्ब एनर्जी गिविंग द प्रेशर ये डायरेक्ट मेजरमेंट कर रहे हैं द वॉल्व थ्रॉटल्स द लिक्विड रेफ्रिजरेटर और लिक्विड लाइन down to a constant pressure a basic refrigerant system with automatic expansion valve is shown in the next figure in this example the compressor the motor and the condenser unit are in base of the cabinet in the base of the cabinet notice is there is no sensing bulb attached to the automatic expansion valve unlike a TXV the AXV does not control superheat it does not control superheat it controls only the low side pressure the low side ka pressure control the refrigerant can flow through a AXV only if the evaporator pressure is reduced below the pressure level so you see this is the exact जो इसके अंदर इसका compressor है ये motor है everything is there so the same thing and ये आपका motor का control element का आपका ये sensing bulb है so you got only one sensing bulb for the motor control which is there ताकि अगर मोटर को what you call कटिंग कट आउट करना तो उसके हिसाब से वो एक सेंसिंग बल्ब है बाकी कोई भी यहाँ पे देखो TXV के यहाँ पे there is no separate sensing bulb so how it works okay in this example the compressor are attached unlike the TXV the AXV does not control superheat control only the low side pressure refrigerant can flow to AXV only if evaporator pressure is reduced below a preset level okay so ये idea है so you see there is no sensing bulb nothing over there we'll see how it controls automatic expansion or operation the automatic expansion valve increases the refrigerant flow when the evaporator pressure drops and decreases the refrigerant flow when the evaporator pressure increases just give me a second
So basically, it works like a pressure reducing valve, sir.
yeah more or less okay now a constant pressure drop रखता है ठीक है this action maintains the constant pressure in the evaporator whenever the system is running as the compressor runs the liquid refrigerant flows through the automatic expansion valve and is sprayed into the evaporator here due to the low pressure the refrigerant boils rapidly and absorbs heat The vaporized refrigerant moves back to the compressor through the suction line. So basically, return line में से suction line में वापस आ रहा है. Okay. Now in the compressor, the refrigerant vapor is compressed to the high pressure side and pumped to the condenser. While flowing through the condenser, the vapor is cooled and the refrigerant gives up the heat and is absorbed in the evaporator and returned into liquid. Right. Now in this, it then flows to the liquid receiver and ready to repeat the cycle. मतलब वही वापस cycle वापस हो गया. The motor control thermal element is clamped to the outlet of the evaporator as you saw here. The thermal element of the motor control is there. And the motor control is turns off the current to the compressor motor. After the compressor stops and the pressure in the evaporator rises, the automatic expansion valve closes. Basic idea वही. The system using the automatic expansion valve is sometimes called a dry system because the evaporator is never filled with liquid refrigerant but with a mist or fog. So ये एक major difference ये भी हो गया. Evaporator is always with a mist or fog. Because the automatic expansion valve is operated by a low side pressure alone, the system operates independent of the amount of refrigerant in the system. This type of system is used widely on small commercial applications. Small applications. Okay. These expansion valves are adjustable. Okay. They permit the opening of the valve by over a wide range of pressures. Okay. Automatic because now you don't have the thermostatic range का आपको limitation नहीं है. कि आपको it is not connected to the temperature what you call under pressure. So automatic expansion valve must be adjusted for atmospheric pressure which affects the operation. Means आपका अगर change होगा pressure तो उसके बाद भी high altitude will cause a decrease in atmospheric pressure and adjusting screw must be turned in, increasing the opening pressure. अपने को ship में तो कोई problem नहीं है ये, but basically it's just mentioning that refrigerant with different evaporating pressures have different expansion valve settings. It's important to remember that the valve capacity should be equal to the evaporator capacity. For example, a 1-ton expansion valve is used with a 1-ton capacity reducing condensing unit. तो वो उसका मैच होना चाहिए. And under the single current where was I here? Okay. An under capacity valve tends to starve the evaporator. Too little refrigerant gets through. An over capacity valve tends to allow too much refrigerant to the evaporator. And when the valve opens, this may cause sweatback or frost in the system line. मतलब अगर आपका over correction हो गया, ठीक है? This term sweatback and the frostback refer to the accumulation of condensation of suction line due to the difference in the line temperature and ambient temperature. So instantly वो frosting हो जाता है on the suction line. Now, expansion valve leaks. The faulty valve or the seat in the expansion valve assembly will allow the refrigerant to leak off during the cycle. मतलब वो equalize कर देगा. This will allow liquid refrigerant to flow into the suction line. And when the compressor starts, this will be indicated by frosting of the suction line. The presence of liquid refrigerant in the suction line may result in liquid refrigerant being drawn into the compressor. Direct आपको liquid आ जाएगा. This can cause the compressor to knock severely and may cause compressor damage. So that's why expansion valve leaks are very, very dangerous. Now, design of it is basically again flexible part हो सकता है ऊपर का. So अभी इसका operation कैसा है? It can have two different designs. Okay, many designs with automatic expansion valve. So basically ऊपर एक flexible part है, either a diaphragm or a bellows. Okay, usually it is made of a phosphor bond and soldered or braced to the wall body. मतलब उसका एक uniform होता है construction, not के separately flange से connected है. जो bellows है, braced है direct. Flexible elements must move in and out of time without losing flexibility. The wall body is usually top forged brass, but sometimes it is cast. It must be the liquid inlet has a soldered connection, standard flange, lead connection, or pipe thread, whatever हो सकता है. Okay, and the liquid inlet is usually equipped with a screen designed for easy removal. मतलब उसके आगे एक filter है उसके. Okay. Now an external view of the automatic expansion valve is shown here. Basically ये लगा देखो ये है. ये आपका वॉल है. तो ये ऊपर आपका डायफ्राम बेलोस है ऊपर. ये हाउसिंग है. उसके ऊपर एडजस्टिंग कैप to adjust the pressure of the diaphragm. And ये आपका इनलेट है. ये आउटलेट है. और this is the direction of the arrow which is showing the exact operation of it. Okay. The external view of the automatic expansion is shown. The arrow indicating the flow direction often from the exit to ensure proper installation. So here it is very important that what flow you are having exactly वो inlet outlet को mix up नहीं करें, because यहाँ पे क्या है कि it is going to give the pressure drop irrespective whatever is the orientation of the pipe. So इसलिए inlet outlet के हिसाब से direction of flow will always to the outlet. You have to understand because that is also a mark. Now the protective cap can be screwed over the adjusting knob, but it is not adjusted more. The cap prevents the adjusting knob being accidentally removed. The wall capacity is often started from the cap, with the O-ring below the cap thread for airtight seal around the cap. This prevents debris from entering the diaphragm outlet and seals the atmospheric pressure. Inside there's always a sealed atmospheric pressure is there coming inside, not directly, it is not directly open. It is basically sensing it from the distance. Now there is a bellows type one and a what you call diaphragm type one. Basic idea kya hai? Therefore, we just see this. There is basically P3 is the inlet pressure. Here you have got the needle wall, and then P2 is basically the evaporator pressure that is going out, and P1 which is coming from the adjusting screw on the diaphragm bellows or whatever is there, which is coming down right up here. Okay. So simple bellows type automatic expansion valve showing the various pressures inside the wall with controls. P1 is atmospheric pressure ऊपर से आ रहा है, ठीक है. तो जैसे आपको बताया कि उसके ऊपर जो कवर लगाया हुआ है उसके ऊपर atmospheric pressure आता है अंदर से. But the cover is preventing any the bellows from getting any dirt. That's why you have got the cover on top. ठीक है. And then P2 is the atmospheric evaporator pressure which is down, and P3 is the liquid line pressure. Okay. So F1 is basically your force one of the spring which is coming from top. एडजस्टेबल प्रेशर ओपनिंग जो आप जैसे कैप से एडजस्टिंग स्क्रू से कर सकते हो ऊपर नीचे, और नीचे वाला F2 इज बेसिकली नॉन एडजस्टेबल प्रेशर क्लोजिंग, तो स्प्रिंग का जो क्लोजिंग प्रेशर है वो वाला. ठीक है. तो आइडिया ऑपरेशन तो वैसा ही है, बट नाउ वी विल जस्ट सी व्हाट एग्जैक्टली हैपेंस हियर. ठीक है. ये तो वही है, इवेपोरेटर प्रेशर P2 ये सब लिखा हुआ है. नाउ यू सी एज द इवेपोरेटर प्रेशर डिक्रीजेस, the pressure difference forces the bellows towards the wall. Basically, it moves downwards. And since the needle wall is linked to the bellows, you see the needle wall is linked kiya hua hai. Needle wall is linked to the bellows. As the bellows move down, it moves the needle wall down. Okay. And the needle wall is linked to the bellows, so it is forced away from the seat. Some liquid refrigerant space into the evaporator, and because of the refrigerant evaporates at a constant low pressure, the evaporator cabinet temperature stay within the design zone. मतलब ये उतना ही टेम्परेचर में रहेगा जितना ये ऑपरेशन के फ्लो के अंदर है. That is the idea. So it will never go out of the idea. That is the idea. तो एक ये डिजाइन है, और एक दूसरा डिजाइन है which is called as a what you call diaphragm type. तो ये bellows type है. Diaphragm type में वही आइडिया है कि there is instead of a bellow there is a diaphragm. तो diaphragm से आप उसको कंट्रोल कर सकते हो. Again the pressure on top of the diaphragm is there. So I didn't want to discuss that again, that diagram again. Just give me a second. Now about electronic expansion valves. We'll continue for a few more minutes. Right. So another type of expansion valve that is becoming popular is the electronic expansion valve (EEV). In this type of expansion valve, an electric operator is used. Means basically some type of a operation device. Okay. Not a man, electrical operator, not a man, but basically a device. Instead of a diaphragm powered assembly of a TXV or the spring assembly of AXV. स्प्रिंग की जगह पे एक दूसरा जगह दिया हुआ. They have been a number of electric operators used over the years, including heat motors, magnetic operators. However, the most common in modern systems is a stepper motor system. Okay, the stepper motor EV. The stepper motor is a small stepper motor which used to drive the pin or piston that operates the valve. The stepper motor may either operate the valve directly through the shaft or may transmit its power to a gear train, which increases the torque. Okay. The stepper motor corresponds to electrical signals sent by a controller by rotating a small, precise and repeatable amount. मतलब उसको धीरे वो stepper motor ऑपरेट कर जाएगा. And this may be as little as 1/24 of a complete revolution of 15 degrees Celsius, 15 degrees is radially, okay, and a lead screw translates the rotatory motion of the stepper motor into the linear back and forth motion, okay, needed to operate and close the valve. तो ये क्या मतलब बोल रहा है, देखो ये ऐसा आपका मोटर हाउसिंग है और ये इसके अंदर एक गियर हाउसिंग. दिस इज द मोटर, दिस इज द वायरिंग कमिंग फ्रॉम द सेंसिंग कंट्रोलिंग एलिमेंट. तो यहाँ पे आपका मोटर है, स्टेपर मोटर के अंदर एक गियरिंग अरेंजमेंट है. यू सी द ओपन व्यू ऑफ दिस थिंग, दैट इज द एंटायर थिंग, ओके. ये वायरिंग है ऊपर का, ये आपका ऊपर गियरिंग कवर है, ये मोटर हाउसिंग है, एंड दिस इज अ गियर ट्रेन इनसाइड, ओके. सो a small cutaway wall, the exploded diagram showing the inner working parts is shown here. Okay, basic diagram. तो ये आपका वो कटवे वॉल का अंदर दिखा है कि गियर ट्रेन है स्टेपर मोटर के अंदर. So this is operating the stepper motor very slowly and going giving the moving this lead screw up or down. अभी lead screw किसमें ऑपरेट करता है, we'll just see again. So as it rotates, it is drawn forward on the lead screw threads as the screw turns. So lead screw will move up or down slowly. And since the direction of wall travel is based on the direction of the rotation of the stepper motor, the lead screw and the stepper motor can open the wall, close the wall, or modulate the wall's position. तो ये क्या कर रहा है, ये देखो, ये जो लीड स्क्रू है, ये लीड स्क्रू स्टेप ग्रेन से ऊपर नीचे जाता है और ये पिस्टन को ऊपर नीचे मूव करता है, ओके. तो इनर पार्ट है ये गियर ट्रेन के नीचे का. Okay, the lead screw is turned up or down by the stepper motor, and as the lead screw turns, the threads on the bottom of it are mesh with the internal threads of the piston, causing the piston to move up and down. The piston will travel up and down on the lead screw. Basically, lead screw is basically going inside the hollow piston, and the piston is basically traveling up and down on this, like a internal what you call threading system. Okay? And the piston basically moves up and down. As the entire arrangement cannot move up and down, the piston basically travels up and down on that. Okay, that is the idea. Now, as since the rotation is precise and repeatable, the controller can precisely position the valve for optimum flow under the widely varying force. Okay. Although one second, in one direction basically it goes upward, and one direction it goes downwards. Okay, you can throttle it, you can have it at any position. Okay, and the controller can precisely control the valve very easily. Although EV is electrically driven and electronic controlled, it performs the same function as a thermostatic expansion valve, restricting the superheat to a desired setting. मतलब ये जैसा आपका जो EXP करता था, वो सुपरहीट नहीं करता था, ये नहीं कर रहा है, ये सुपरहीट को ही कंट्रोल कर रहा है, जैसे आपका EXP कर रहा है. तो सुपरहीट is the temperature difference between linear and hot evaporator basically. As with the thermostatic expansion valve, the inputs are used by a thermostatic expansion valve are low side pressure and the temperature of the evaporator outlet. So both of them are used. Low side pressure as well as the temperature of the evaporator outlet is used to control it. The pressure reading is supplied from a pressure transducer and connected to a suction line using by a connection. Basically, SAE connection दिया हुआ है. A pressure transducer is a device that converts the pressure into a signal, and the signal controller can be used. मतलब इसके बाद एक pressure controller से ये signal को transmit करता है. So that is basically what is controlling the stepper motor, whatever the sensing is there. Okay, this is the pressure transducer. Okay, it basically measures the pressure at the evaporator outlet and sends the corresponding signal to the control. Okay, it also measures the temperature. Temperature को भी control करता है, pressure को भी control करता है. Both of them are controlling. Okay, the evaporator temperature input is sent to the valve controller from a temperature sensor mounted on the suction line near the evaporator outlet. A temperature sensor is an electrical device used to measure the temperature of it. Not like your bulb and everything, that just like an RTD, resistance thermocouple or thermistor, ये लगाया हुआ है. Okay, thermocouple or thermistor लगाया हुआ है, not RTD. Both the temperature transducer and temperature sensor is placed on suction line in the same location where the sensing bulb and the together be placed installed in TXP. Exactly similar है, जैसा आपका TXP पे पोजीशन था, वैसे ही आपका ये इसका sensing bulb में दिया है. ठीक है. The controller is placed nearby and receive the pressure and the temperature signals as you see here. तो अभी ये इलेक्ट्रॉनिक इक्वलाइजिंग वाल्व है. ये प्रेशर ट्रांसड्यूसर एट द आउटलेट, यहाँ पे आप अपना इक्वलाइजिंग कनेक्शन लगाते थे, और टेम्परेचर सेंसर which is basically generally measuring your basically your entire thing outlet is similarly doing it. ठीक है. तो आइडिया वही है कि जैसे आप वो लगाते थे आपका इक्वलाइजिंग कनेक्शन, और ये भी वही काम करता है. तो प्रेशर दे रहा है डायरेक्टली एंड इट इज आल्सो मेजरिंग द टेम्परेचर. ठीक है. दैट इज आइडिया. So this is the electronic equalizing valve का general control. Okay. we won't go much into this because इसके अंदर तो आपको बहुत जा सकते हो ये कंट्रोलर कैसे काम करता है and everything. But ये बेसिक आइडिया होना चाहिए कि कैसे ऑपरेट करता है. This is the basic idea which we have got. ठीक है. So that is the this thing about your EV. Now once again, we won't talk much about EV. We have to still talk about two other type of metering devices. That is your um, low side float and high side float. वो मैं आपको कल दिखा दूंगा and then we will start with other operations. ठीक है, operation of the circuit basically control कैसे करते हैं, how the system works and everything we will do that. ठीक है. Any particular topic in this you want me to cover independently other than that? Let me know also. वो भी मैं कवर कर दूंगा अगर कुछ आपको लग रहा है कि कुछ पेंडिंग है. ठीक है, बिकॉज ये TXV के बारे में और AXV के बारे में काफी पूछते हैं और EEV के बारे में पूछते हैं, तो आई थॉट आई विल कवर दिस मोर विद बिट इन डेप्थ. बाकी वो हाई साइड फ्लोट लो साइड फ्लोट इज जस्ट अ फ्लोट सिस्टम. वी जस्ट गो थ्रू इट इन वन और टू फोटोग्राफ्स. ठीक है, वो देख लेंगे and then we will come continue with something else in this refrigeration and करते हैं. ठीक है. I will try to meet again at 9:30 के बीच में. I will let you know. ठीक है. चलो guys, let's meet tomorrow and any doubts let me know. ठीक है. चलो, good night guys.
Good night, sir. Thank you.
Good night.
Right.
Good night.